Hello guys, welcome to my channel. In today's video, we will be discussing about the Leetcode problem number 1722, which is minimum Hamming distance after the swap operations. Okay, so I will suggest you to first read the question thoroughly, and after that come to this solution, come to this explanation. And if you don't understand, if you able to get the question, so you can solve it by yourself. So let's discuss the what the question is saying. You are given two integer arrays, source and target are given to us. Source and target. Okay. Both of length n. So both of their lengths are equal. You are also given an array allowed swaps. Okay. Where each allowed swap consists of AI and BI. Means these are the indexes which are of source or target array. So this can be interchange, means this can be able to swap, okay, with themselves only. Okay, now what is given again after that? Indices that you are allowed to swap the elements at index AI and BI. So these are the elements, these are the indexes which we can be able to swap. Okay, so zero index indices are given in this allowed swaps. Okay, so what in the source, okay, this indices belongs to the source array and we have to make them as a target. Okay, so note that you can swap elements at a specific pair of indices multiple times in any order. Okay, so multiple times we can swap, and again in any of the order we can swap them. Okay, the Hamming distance of two arrays of the same length, source and target, is the number of positions where the elements are different. Means the Hamming distance are the number of positions where the source and target are different. So initially if we have 1 2 3 4, so here we have 2 1 and 4 5, so all the elements at same index, means at 0th index 1, here it is 1 is present, here 2 is present, so they both are different. So that's why the Hamming distance will be 4, because all of them are different at their particular indexes. Okay, now after that what is given, that Hamming distance. So how we will be calculating the Hamming distance I have discussed now. Okay, then what we have to do, we have to return the minimum Hamming distance of source and target after performing any amount of swap operations on array source. Okay, so we have to return the minimum Hamming distance. Okay, return the minimum Hamming distance which can be possible. Okay, so what we will do now here. Okay, so how can we do and what we will do here. Okay, let's see the source. 1 2 3 4 it is. I will just write the example only. 1 2 3 and 4. 1 2 3 4, and then we have 2 1 4 5, 2 1 4 5. Okay, and allowed swaps are 0 1 and 2 3. Okay, these are the allowed swaps. Okay, so this is the array, this is the source, this is the target array. Okay, so we have to find out the minimum Hamming distance. Okay, so to finding out the minimum Hamming distance, what we will having what we were doing, that it is given that we can swap 0 and 1. Okay, so we can swap 0 and 1. So just I will write, so 0 1 2 3, so these are the indexes. Okay, so we can swap 0 and 1, 0 and 1 we can swap. Then again we can swap 2 and 3, 2 and 3. So just I will represent it with the different one, 2 and 3. So we can swap 0 and 1, and 2 and 3 are different. Okay, 2 and 3. Okay, so what we can be able to justify from this? So when we be able to swap many different positions. Okay, so let's take the long example first. 1. Okay, so if we have 1 3 3 4 6 7 8 2. Okay, so this is the example which is given to us. Okay, So and also it is given to us that, so these are the indexes 0 1 2 3 4 5 and 6. So it is given to us that we can swap we can swap third index, second index, fifth index and zeroth index. Okay, if it is given to us that we can swap 0 to 1, means we can swap 0 to 2, 2 to 3 and 3 to 5. So if this condition is there, okay, if this condition is there, so let's assume that so what you can be able to optimize, what you can be able to observe from this, that if these are linked with each other, means you can swap 0 to 2, 2 to 3 or 3 to 0 or 3 to 5. Okay, so if they are linked, okay, it's making a graph like situation. Okay, means 0 can be swapped with the second 2 and 2 can be swapped with the 3, 3 can be swapped with the 5. Okay, so this is making a graph like situation, means the number which is present at 0th index can also go to the 5th index. The number which is at present at 2nd index, it can go to this index or 0th index, 3rd index or 5th index. Okay, so any of the number which is present on any of the index, so it can go to the 5th index, 2nd index, 0th index or 3rd index itself. So these can be the possible positions after swapping the indexes. Okay, so from this again, so these are linked to each other, okay, like a graph like situation. Okay, now let's see that if 1 and 4 can be able to swap with each other, then 6 can be able to swap with the 1. Okay, so what you can be now observe that this 6, 1 and 4 all are linked with each other like a graph like situation. Okay, and now if they are linked with each other, so this 6 can be if we have to move this 6, the number which is present at this 6th position, so it can be first move to the 1 and then we can be able to move it to the 4th position. Okay, 4th index. Okay, so means what you can conclude that the indices which are linked with like a graph like situation. Okay, so the indices which are linked can be moved to any of the positions to which they are linked. Okay, so this is the graph like 6 is linked with the 1 and 1 is linked with the 4, and another graph which we can make is 0 is linked with the 2 and then 2 is linked with the 3 and 3 is linked with the 5th index. Okay, so these are the two graphs which we can make, and now from this one we can show that this the numbers which are present at 6, 1 and 4. So the numbers which are present at 6, 1 and 4 are 8, 6 and 1. Sorry, 8, 6 and 1. Yes, so these are 8, 6 and 1. 8, 6 and 1. Okay, and now here the numbers which are present are 2, 3, 4 and 7. So these are the numbers which are present at this graph. Okay, so now so this graph numbers can be moved to any of the their graph adjacencies. Okay, so they can be moved to any of the indices in the graph which are present in that particular graph, and this also so the number which are present at this graph also, they can also be moved towards any of the indexes. Okay, now 8, 6 and 1 we can move towards any of them. Now let's decide that if we have this as a target. Okay, let's move towards move this towards. Okay, yes, now we can move them to any of them. Okay, okay, yes, now again this is the now source is given to us. Okay, this is the source. Okay, let's discuss what will be the our target. Okay, let's okay, yes, so this is the source which is given to us. Okay, I have marked every graph nodes as the indexes, and now let's discuss what will be our target. So this is our source array, and now let's discuss for our target array. Okay, which is our target array. So let's 2 1 3 4. Okay, so this is a 3 1 2 4. Okay, we can take any of them, 7 6 and 9. Okay, so let's this is the our target array. I will mark this indices. Okay, 0 1 2 3 4 5 and 6. Now these are the indices which we can mark. So let's group this together. So this is the group of red, so 6 is also in the red group, and the green group is sorry, third is in the red group only. Okay, third is in, okay, yes. Now I have marked this all the red and green groups. Okay, now what we can do that we can find out whoever are in the red group and which of the elements or which of the indices are in the red group, which of them are in the green group. Okay, so firstly we just find out the indices from source. Okay, we just find the indices from source green group. Okay, just we will solve for green group. Okay, so green group, the indices are not the indices, the elements. I am talking about the elements. The this is the one, this one, this one, and this one. So these are the elements which are present in the green group, 2 3 4 and 7. Okay, and this is from the source. Then I will find out from the green group from the target array. So this is the 0th index, so 3 2 4 and 6. Okay, 3 3 2 4 and 6. So these are the 4 which we found in the green group from the target one. Okay, so now how we will match them, as we can get the minimum Hamming distance. Okay, so the Hamming distance, how to minimize it. So how to minimize it, that to minimize it we have to shift this 2 to here at the second index, and 3 to this at the 0th index. So what will be our target one? The source will be changed to, I will just rewrite it only, the source will be changed to 3 and 2. So now this index both are same, means source and the target positions are same. Okay, the element which are present at the same indices are same. Here it is also at the second index, at the 1th index it is also same, at the second index it is also same, but at the 4th index it is different. So how we will solve this position, means how we will solve this, by using which data structure we will approach this solution. Okay, so let's discuss this. This is the okay, so this is how we will approach this solution, that by using the map. Okay, firstly we will figure out which of the indices are linked with each other by using the graph, or you can use union find also, but it makes more complicated by using the union find. But if you use the graph, so it makes it more easy to solve. Okay, now after making the graph, how we will approach this, that the greens from the, means the numbers, the indices which are present at the one graph. one similar graph, because there can be many of the graphs which can be present. Means if any of the element, okay, if any of the element is not able to swap with any of them, means because it is given that allowed swaps, so 0 and 1 it is given to us, but yes, in this one it this allowed swap is empty, so that's why the graph will be 4. Okay, means this is having one graph, means index 1, index 0 is having one graph, index 1 is having one graph, index 2 and 3, so both are having the individual graphs, so there can be 4 graphs. Okay, so in this way we will have to group our graphs. Okay, so after having the graphs, so we will store this 3 and 2 and 4 and 7. So this all the numbers, means all the elements which are present at that particular index which is present in the particular graph, so we will group them in a map. Okay, now after this, so our approach is that we will group them in a map. So nums of I, okay, we will increment it by nums of I. Okay, and after that which are present in the target one, so we will so this can be the source, this can be the source, and this can be the target, and the elements which are present in the target we will decrement their values. Okay, decrement them from the map. Okay, so I will just rewrite it more. S of I, we will increment them, and which are present at the target, so we will decrement them. Okay, so now after decrementing them, what will happen? So when we increment 3, so and here it is a target, here in the target we are decrementing 3. So are you getting it or not? So we are incrementing so we are incrementing our 3 by using the source, and we are decrementing 3 from target, so this can be balanced. Okay, so the Hamming distance will be 0 now. Then from the sources 2 is getting increased, and from target 2 is getting decreased, so our source our Hamming distance will also again balanced. Then for the 4 it will get balanced. Now for 7, so the map size, means in the map 7 size will be 7 size map of that 7 will be increased as 1. Then again map of 6 will be decreased as, means initially it will be 0, so it will be as a -1. So here we have got -1 and 1, so both are different. So to balance this situation, so these are the two elements which we got as a unbalanced. So now for this solution, answer will be, what will be the answer, means what will be the maximum Hamming distance, sorry, the minimum Hamming distance which we will be finding out, will be the Hamming distance will be calculated as the unbalanced elements which are present there. So the unbalanced are 2 which are present here. So how we will be finding out that? So we will have to make absolute from this as a means map. So this one and this one both will be calculated 1, and the absolute of again 1. So this will be converted into the 2, and these are the unbalanced one. Okay, unbalanced from the source as well as target. And if we have to balance them, if we have 4 unbalanced elements, so we can balance them as from the 2 from sources, 2 from source array, and 2 to the target array. So there will be 2 unbalanced from source array, 2 unbalanced from target array. So the Hamming distance will be 2. Okay, so in this way our solution will work. So let's discuss how we will be implementing it in our code. Okay. So this is the minimum Hamming distance function. Here what we are doing, that we are taking the unordered set. So we are taking unordered set to minimize the repetitive elements, repetitive edges. Okay, and we are making simply the graph which are the indices are linked to each other. Okay, so these are this is the graph which we are making. Then we are mentioning a visited array, which of the means which of the indices are visited till now or not. Okay, means if any of the graph means just we have discussed as a green and red graph, so after visiting them we will not visit again for them. Okay, now in the count, so the count is storing the answer, means the maximum Hamming distance which we are getting. Okay, so if it is already visited, so we will not be able to visit it again and again. Okay, now we will apply the breadth first search first for every indices if it is not visited till now. So then we are passing here source and target also. Okay, so all the working is done in this BFS function only. So now in this BFS function, as we discussed, we have to make a one map, and for traversing all the edges, sorry, all the nodes of that particular graph, so we have to take one of the cube, and the current will also push to the cube first. After that, by using the BFS algorithm, we will just visit all of the nodes. Okay, all of the nodes, and while visiting all of the nodes, so we will just mention the map of that source of current, means the element which is present at that particular index, we will add them, and the element which is present at the target, we will, so it will balance our array. And after balancing it, okay, after balancing it, what we are calculating, this is the for loop which is calculating the Hamming distance, or we can say that the number of elements which are unbalanced. Okay, so we have two arrays, so the number of elements which are unbalanced can be distributed into these two arrays. Okay, so that's why we are dividing it with the 2. Okay, so when we have two unbalanced numbers, means when we have 8, when we have 9, means these are not balanced. Okay, so this can be in the source and this can be in the target. So in this way we can balance them. So to calculate the number of elements which are unbalanced, we are only adding the absolute of I dot second, means the number of elements which are present in the map. Okay, so in this way this will return the result divided by 2 to balance them in a Hamming distance, for calculating the Hamming distance. Okay, and in this way we will add for every of the graph and we just return the answer. Okay, and hope you got the solution. Thank you for watching this video. See you next time.